Here is all my work for this one at the beginning, in case you just want to see a bunch of the work right there. You can kind of get some stuff down if you need to. I'm going to try to talk through quickly A, C, and D for this one, and then I'll spend a little bit more time talking about letter B, because I have two ways I can show you how to do letter B that I'd like for us to kind of understand both. All right, now letter A just says, where does F have a local min? Local min is the same thing as a relative min. So you got to think, all right, let's do that justification first. We know F has a relative min or a local min where the derivative changes from negative to positive, right? And then so this is your derivative graph. So if I ask you where does the graph change from negative to positive, you're thinking where does it go from below to above the x-axis right there? And that's right here at x equals 6, where your derivative graph has negative values and then your derivative graph changes to positive values. So F has a relative min or local min at x equals 6 since the F prime changes from negative to positive. So usually I try to talk myself into the right answer first, get that answer, and then I guess I could probably just kind of circle a bunch of that right there. As long as you have that answer there, and then the F prime change from negative to positive will be good. Let me skip over letter B for a second there. Letter C says, where is the F both concave down and increasing? And lately they've been liking doing two different things like this. Now, here's what I know. If F is concave down, that means the second derivative is negative. If F is increasing, that means the first derivative is positive. And since I give you the first derivative graph, if I ask you where is that given first derivative graph positive or negative, I want to know is that above or below the x-axis. Does it have positive y values? So over the first derivative graph is positive, that's where first derivative graph has positive y values. That's where that given graph is above the x-axis. So I'm just going to box that for now. Okay, I'm not worried about finding that and then doing that. I'm just going to box that for now and get all my answers at once. When you're going from the first derivative to your second derivative, we know that's the slope, okay? That's the slope of the F prime. So if I ask you where is the second derivative negative, that's the same thing as asking where is the slope of that first derivative negative. So where are the slopes of that graph negative? That's where that graph is decreasing or going downhill. So where this graph has a negative slope, where this graph is going downhill, that's where its derivative is negative, and that's where the second derivative is negative. That means the original graph will be concave down right there. So what you're looking for, I just like doing that, thinking at the beginning, and then it's easy to find that answer. I'm looking for where is it both above and going downhill. So that's in between the 0 and the 1, and then between the 3 and the 0 and the 1, and then the 3 and the 4. Those are my intervals right there. And we always use parentheses for that. Letter D, I thought was a pretty easy problem. They give us a power, and it just says, what's the slope of the line tangent? It doesn't say write the equation of the tangent line, so I don't need to do point slope form. It just says, what's the slope of the tangent line, which is your derivative. So you're gonna do, this is a power. We're gonna multiply by the power, leave the inside alone, decrease the power by 1, times it by the derivative of the inside, and then it says add 3. So you gotta plug in 3 for the x's. Now, f of 3, they told us flat out that was equal to the negative 5 halves. So that's where that came from. And in f prime of 3, that means on my derivative graph at x equals 3, what's the y value? So now if this is my f graph and they're asking me for f prime of 3, I got to look at that f graph and I got to figure out what the slope of that is. So they'll probably give me a line segment. I'll do the slope of the line and I'll put that right there. But this is your derivative graph. So if I say what's f prime of 3, that means you just look at x equals 3. What is your y value on that derivative graph, which is equal to 4? And then this is no calculator. Make sure you're practicing all of these without the calculator, except for the first couple. But then the 4's cancel out nicely. I just got 75. Now let's do a little extension. If it did ask for the equation of the tangent line, then you need a point. We know the x value is 3. But if I had to figure out the y value, I would have to plug that 3 in right here. So I would have had to have done g of 3 equals f of 3 cubed like that. And then f of 3 was that negative 5 halves cubed. And then that would give me what? Negative 125 over 8. So that would have been my y value. 3 is my x value. And then if I have that point there, and then we figured out that the slope is equal to 75. So then I could do my point slope form. I can go y plus 125 over 8 equals 75 times x minus 3. But that's only if it's asking for the equation of that tangent line. So just the slope of the tangent line, that's just your derivative, and then you're done. All right, now let's get to letter B. That was the toughest part of this one. It says absolute min, all right? So here's how I know I'm doing this, because it says absolute min, and it gives me a closed interval. This is not the first time we've seen this on your blue packet, absolute min on a closed interval. we're going to need to make an XY chart, check the endpoints and the critical numbers. So right away, I'm making an XY chart. The endpoints of the interval are on there, and I got to find the critical numbers. Now, since the critical number, since this is asking for an absolute min, the critical numbers is would be a relative min. All right. Now, technically, wherever that first derivative is equal to 0, those are critical numbers right there. I don't need to concern myself with this critical number at x equals 4 because here my derivative changed from above to below. So my derivative changed from positive to negative. That would be a relative max on my original graph. So if it was asking for an absolute maximum, I would check that on my XY chart. But here I know a relative min at x equals 6. That's what we found in part A. There's only one relative min. So since it's a relative min or a local min, and now we're checking to see if it's an absolute min. It could be the lowest point on the graph, or that title might go to the endpoints of the interval. That's why you always have to check both. We've had these where a lot of times it will occur at that critical number, and then sometimes it can have the potential to occur at the endpoints, which it does here. So that's how I just obtained that one for my critical number. You could have thrown the 1 and the 4 in there if you wanted to, but then you're just checking more stuff and it would not have given you the lowest Y value. All right, so let me talk about 2 different ways of how to do this. One, they gave us f of 8 was equal to 4. They told us that right there. So f of 8 was 4, that one was given. I just gotta calculate f of 0 and f of 6 by myself. Now, one way we did this in the past is we said, okay, to get from the f prime to the f, we know we're supposed to integrate that because this is the f column right here. So when I integrate f prime, that gives me f of x. We got to choose the 0 because that's what we're trying to figure out. And the reason I chose that 8 is because that was what we were given. Okay, I think this on the very first test that we've done, earlier in the year, that's the f of 8 equals 4. So then when I integrate f prime, I get f, plug in the 8, plug in the 0. F of 8 they told us was 4. F of 0 I don't know, so I carry that down. And then your number representation of your integral is area. So you got to do the area of that derivative graph in between 0 and 8. Now this one was super nice, I thought, because they flat out gave us all of those numbers. They had to because everything was curvy. Usually they give us the rectangles and the triangles and the semicircles, and we need to use geometry to kind of figure out those areas on our own. But remember, if it's above the x-axis, the integral is positive. Below the x-axis, the integral is negative. So I'm just going to go 2 plus 6 minus 3 plus 7, and that's going to give me 12 for that area. And then what I did, I moved the f of 0 over here, and I subtracted the 12 over there to get that f of 0 was a negative 8. And then a similar approach right there, I'll let you figure that one out on your own there. But I chose the 6 because that's what I was trying to figure out. I chose the 8 because that's what we were given. And then you're just doing the area in between the 6 and the 8, which is flat out equal to 7. Now, that technique kind of works. It kind of makes sense, or it should make sense. All right, you're just integrating the derivative to get to your original function. There's going to be something we do in the future where this other thing is going to be kind of helpful for us, all right? Think about the integral as an accumulator. It'll accumulate all those areas as you go from left to right. So I can do this. I can go f of 8. It's like you always got to do that initial position, right? So f of 8, this is like f of 0, right? Kind of like what the initial position is. And then you're going to add in all the areas all the way up to the 8 number there. So that's why I did f of 0, and then I did the 2, 6, negative 3, minus 7. Those are just coming from my areas up there. And then see, they told us f of 8 was equal to 4. So then instead of f of 8 equals that, I just got all that stuff is equal to 4. And then I got carried down the f of 0, combined like terms. 4 minus 12 gave me also that negative 8 number right there. When you do f of 6, you got to start at f of 0. That's your initial amount. And then you're going to go all the way up to x equals 6. So you're going to do the area. You're going to go 2 plus the 6 minus the 3. And then you're going to stop it right there. And then we already found that f of 0 was negative 8. So you go negative 8, just add those numbers up, and then you're going to get that negative 3. So as you go left to right, it'll accumulate that total for us. So we'll come back to that. I'll show you that again in the future, and we'll see another video explaining how to do some of that. Chocolate.